Hey everyone, this is your key for your Chapter 6 study guide all about electricity. So your first question was to fill out the chart with the particles that atoms are made up of. We talked about atoms at the very beginning of this chapter, and we said that they are made up of three things, and they were protons, neutrons, and electrons. And an easy way to remember their charges that go with them is that proton starts with a P, and so it's positive. So proton, positive. Neutrons are also easy. Neutron is neutral, so they don't have any charge. And then electrons are negative. So your chart should look like this. Question number 2 is, what is static electricity? And how is it responsible for the shock that I receive when I touch the door handle in my classroom every single time? Well, all that static electricity is, static means not moving, and then you have electricity. So it's electricity that has had no place to go. It's just sitting there. So what it is it's excess electric charge just sitting on an object. And why it shocks me is that as I walk, my shoes gather electrons from the carpet, okay, and they're just sitting on the rubber of my shoes. And then when I touch the door handle, it is a conductor, a much better conductor than I am, so the electrons go right for it. So I get that little shock that happens when it discharges. Third question, what is the law of conservation of charge? That should be a pretty easy one. We've had law of conservation of energy and everything like that, so you just change the wording a little bit. This time, charge can't be created or destroyed. Number 4 says, unlike charges blank and like charges blank. Well, we did that demonstration with the magnets, and what happened was when we put the two south ends of the magnet, they would not go together. They kept flipping around so that the north and south could be together. Same thing is true for positive and negative charges. Unlike charges attract each other, and like charges repel. And so I drew a little picture to help me remember. So I drew two positives, and they don't like each other, so they're going away. And then a positive and negative, they like each other, so they're coming towards each other. And then an electric field, you can think of it as the thing that surrounds anything that's charged, and it's what causes things to either attract or repel each other. So there's that. And then number 6, comparing the strength of gravitational force to electric force. Actually, we talked about this a while back also, but electric force is much stronger than gravitational force, which is kind of crazy to think about. And then number 7, whether or not charges will move in a material depends on how tightly its atoms hold on to, well, what causes electricity? What it's named after, electrons. It all depends on movement of electrons. Electrons are what allow us to have electricity. Then number 8, materials that electrons move through freely, so things that allow electricity to pass through them easily. We've tested a bunch of these, and they are called conductors. And then 3 examples could be anything you guys can remember from our labs, but remember that metals are the best ones, and we also know that pencil lead conducts electricity, so that's a good one to add. Number 9, materials that electrons are not able to move easily through. So the opposite of a conductor is an insulator. And then some examples of insulators, you could have picked anything that doesn't conduct electricity, so I chose plastic and glass. Those tend to be the best ones. Remember that our wires in our labs are wrapped with plastic so that we kind of have a protection against the heat and electricity. And then number 10, if you rub a balloon on a sweater and it becomes negatively charged, what had happened was that electrons were transferred from the sweater to the balloon, and the process is called charging by contact. Rubbing two things together, they are in contact with each other, and they're getting opposite charges, so charging by contact. So now, number 11 on the second page, what is lightning? We learned that the clouds and the swirling of the clouds causes a lot of electricity up in the clouds, and it's static. So what's going on is eventually all of that buildup leads to a gigantic static discharge, which is what lightning is. And then what causes thunder is question 12. And what happens is, as that lightning is moving through the air, it is so hot that it heats the surrounding gases, and that causes them to expand really, really fast. And when they do it so fast, it causes a huge sound wave, and that's what we hear as thunder. So, air expansion producing sound waves. Number 13, the purpose of a lightning rod. You put them at the highest point in your building so that when lightning strikes, it hits that tallest point, and then that lightning rod directs that charge to the ground so you don't have any charge building up in your building. Number 14, describe how an electroscope works. What does it mean if the leaves are spread apart? And then describe what the leaves are doing in an uncharged electroscope. So that had 3 parts, so I have 3 parts here. An electroscope detects electric charge. You have a picture of it in your notes. And if the leaves of an electroscope are spread apart, that means that they've been charged. And so whatever object, if it has a negative charge, that means the leaves will both have a negative charge, which means they don't want to be near each other, so they spread apart. And then if the object is uncharged, then the leaves just hang straight down normally. And then describe an electric current, and what does it have to do with a circuit? It has everything to do with a circuit. So an electric current is simply the movement of electric charges in a single direction. And then the current is the path the circuit is the path that the current follows. And then describe a type of battery that's a dry cell and a type that is a wet cell. So the dry cell batteries are the typical ones that you think of, so AA, AAA, things that you buy for your devices at home. And then a wet cell battery is a car battery. Number 17, define resistance and state what unit it's measured in. Well, resistance is just like it sounds. It's when objects resist the flow of electrons, so they don't want electricity flowing through them. And it is measured in ohms. And then what 3 factors affect the resistance of a material? The temperature, length, and thickness. So things that we can do to increase the resistance of something is basically to inhibit the flow of electrons. So we can raise the temperature, we can increase the length of the object, or we can make it thinner, so make it harder for the electrons to flow. And so conductors that allow electric current through pretty easily have low resistance, while insulators have high resistance. Okay, and since we measure resistance in ohms, we had to mention Ohm's law, and that is that current is equal to the voltage difference divided by the resistance. And now we're on to circuits. So defining a series circuit, that's where the circuit only has one single path to follow. We built these on the computer, we built these in person, so we should know what these are by now. Now, defining an open circuit. And an open circuit is any circuit that has had a part disconnected to where it can no longer operate. Okay. And then defining a parallel circuit. So the difference between it and a series circuit is that the current has 2 or more paths to follow. Okay. So if we disconnect one piece of them, they are still able to operate. So then I drew a couple of pictures, which hopefully you guys have them in your notes, and you can draw them however you remember them from the labs. The labs are going to be a big part of your test. You'll have to be able to think back on them, so you might think about that a little bit. Maybe play with that computer program that we had on Classroom. So our next question, question 26, says houses are wired in blank. So what type of circuits would houses be wired in? If you think about it, series circuits wouldn't make much sense, because if you turn off one thing in a series circuit, everything goes off, and we don't want our, lights to go off when the microwave is turned off. So Houses are wired in parallel circuits, while Christmas lights, on the other hand, which we have experienced, are in parallel circuits. Okay, so houses are wired in parallel circuits, while Christmas lights are series circuits. And 27, what is the role of a circuit breaker in a circuit? Well, in our houses, if the heat gets to building up too much, we don't want it to cause a fire. So circuit breakers, their purpose is to prevent fires in our homes by opening the circuit when heat builds up. And so there are two ways you can do this. You can either have circuit breakers or you can have fuse box. So circuit breakers, how they work, you have a piece of metal that when the heat in the circuit becomes too great, it bends, and which is flips a switch and opens your circuit. So it shuts off the power. And then number 29, how a fuse works. It's similar. You have the piece of metal, but instead of bending, it actually melts and opens the circuit permanently until you replace the fuse. So now, defining electrical power. Anytime you have any type of power, it's the rate at which something happens. So in this case, it's the rate that electrical energy is changed to another form of energy. And so how do we calculate this? Well, the electric power is equal to your current multiplied by your voltage difference, and power has the unit of watts. So then a couple of example problems. A toaster is plugged into an outlet where the voltage is 120, so that would be this right here. And then it says, how much power does the toaster oven use if the current is 10? So we know the current is 10 and the voltage difference is 120. So all we're going to do is multiply the two, and we have 1200 watts of electric power. Number 33, a video disc player that is not playing still uses 6 watts of power. So we know this already. We use 6 watts of power. So what is the current into the disc player if it's plugged into a 120 volt outlet? So we know voltage and we know power, so we have to solve for current. So I just plugged in my values here. We had 6 for power equal to current, which we don't know, times 120. So if we use our algebra skills, all we do is take 6 divided by 120, and that gives me my answer of 0.05 amps. Now, number 34, a flashlight bulb uses 2.4 watts power. So again, we have the power that we know. When the current in the bulb is 0.8 amps. So we know the current also. We know power and we know current, so we have to solve for voltage difference. So I wrote that up. 2.4 is equal to 0.8 times V, which is our voltage difference. So I'm going to take 2.4 divided by 0.8, and that's going to give me 3 as my voltage difference, so 3 volts. All right, that's it. Study hard, you guys. Parent-teacher conferences are test night. Keep that in mind.